All right, hey guys, we're going to discuss how to do multiplication in different bases today. So one thing that's important to note is that the method is not actually that different from what you already know how to do. The main thing is just wrapping your head around how to work with those different bases, right? So the first thing that I want to do is just go over an example in base 10, something that we all really should know how to do, multiplication. And, of course you get tested in multiplication and in addition, right? Because multiplication, the way that we've learned it, is a two-step process. First, you multiply numbers. Second, you add them. So let's get started with the first example. Very simple. We just take the first digit here and we multiply it by the second digit. But let's first step back and think, what do we need to know about base 10? Base 10, we only have these digits, 0, 1, up to digit 9, right? We stop at digit 9. 10 is a combination of two different digits, right? So we just stop there. Now, when we do multiplication, like in this case, 2 times 5, what do we get? Well, we get 10, right? We memorize that it's 10, but we have to understand that, we put this 0 here, right? And then we carry a value. So that's what we're going to be doing here. We need to understand, when you multiply, you stop and you look, does this whole value here fit in these digits 0, 1 through 9? And if not, then we have to put a carry, right? So this first operation, 2 times 5, gives us 0 with a carry of 1. Then we do 5 times 1 plus 1, so that's 5, plus 1, that's 6. So we get 6 here. And then what do we get? We get 5 times 4, so 4 times 5 is what? Well, it's 20, right? So we take the 0 and we carry the 2. And of course, there's nothing here. So what we do is we just add the 2. Really straightforward. Next thing that we do is we're going to shift, right? So this is where you hear shift and add. Well, you remember adding a 0 here right before you start, right? You can also just, put an arrow here or put a star here, whatever you want. Just know that you're, shifting a place. And it makes sense because now we're actually multiplying by 70, right? Multiplying by 70 rather than 7. That's why we start in the tens place rather than the ones place. But I'll just add in a 0 here because that's what we're really used to. So let's put 0, and then let's do the multiplication. So we have 7 times 2, and what's 7 times 2? Well, it's 14, right? So we're going to take that value 4 and carry the 1. So let me just get rid of these so that's clear. So that blue part is for the second one, right? So that's that carry there. And then we have 7 times 1 plus 1, that's 8. So we don't need to do any carry because 8 fits in, it's less than 9. And then lastly, we have 4 times 7. Well, you know that the operation 4 times 7 will give you something bigger than 9, so let's just write it out. So that would give us 28. So we put 8 here, carry the 2. Well, the 2 just gets put down here. So it just goes here, and then we're done, right? And we have to add these numbers together. And the reason why I'm doing it in this method here is because you'll see that you can extend it to the next base or to different bases. So what we do is we add these numbers here, and then we check, okay, does it overflow? Does it fit into our, 10 digits? And if not, then we do carries, right? So what's 0 plus 0? It's 0. What's 6 plus 4? That's 10, right? But, we only take that first digit, right? We only take that first digit here, put it in, carry the 1. 8 plus 1, that's 9. 8 plus 2, well, same thing as 10, so we take that 0, carry the 1, and then we do 2 plus 1, and that's 3. So the answer, in this case would be 30900 base 10. We know how to do this, right? But the methodology is exactly the same for the next type of question. So let's go into this example in base 4. Well, what do we need to know about base 4? So base 4 has only 4 digits, right? It has 0, 1, 2, and 3. Now, when we do our multiplication, we do it exactly the same way. But then we don't check for if it overflows into 10, right? We don't check for an overflow of 10. We check for when it overflows to 4. So if it becomes 4 or greater, like for example, if you did 2 times 3, which would be 6, right? this isn't a possible result. 6 isn't a possible result because we don't have that digit here. So then we have to then use another place here to store our number in base 4. But let's go through this example so that we actually see how that works. So let's do the normal multiplication. We have 2 times 0, that's 0. 2 times 1, that's just 2, right? Because we have, it doesn't overflow. It's one of our available choices. But now we have 2 times 3, right? We have 2 times 3. So what are we going to do? Well, let's do it. 3 times 2, that's going to be 6, right? But now we need to convert 6 into base 4 because we need to write it, in this form. We have to write it with only using these digits. So what even is 6? 6 is just 4 plus 2, right? So, and if we think about how that works, this would be 1 times 4 to the power of 1 plus 2 times 4 to the power of 0. So we take these two digits, 1 and 2, and we say, okay, well, that's our number. That's 6 in base 4. So we're going to take that first digit here, and even then we could just get rid of this and just say, okay, 3 times 2 is equal to 1, 2. Take that first digit, carry the second. And that's how we're going to do this conversion. So then we do 2 times 2, that's 4, and then we have 5, with that additional 1. So, 5 is equal to, it's almost the exact same. It's 1 times 4 to the 1 plus 1 times 4 to the 0, which is, again, 1 less than 6. If 6 is 12 in base 4, then, we have 5 would just be 11 base 4, right? That makes sense. So we take that first digit here, right? And then we carry the 1, and we get that. So let's go to the next stage. So we're going to add a 0 just like we did before. We're going to shift, and then we're going to do our next stage of multiplication. So let's do 3 times 0. Well, that's just 0. That's just 0. 3 times 1, that's 3. That's fine. Fits in. We've got 0, 1, 2, 3. 3 times 3, well, that's 9. So 9 we can't store in just the digits 0, 1, 2, and 3. So we're going to need to rewrite it in base 4. So what is 9? Well, 9 is just 8 plus 1. So that'd be 2 times 4 to the 1 plus 1 times 4 to the 0. So that means that we would have 21, right, as our value. So 2, 1. I believe that's right. So, we'll take it and we'll say, okay, 3 times 3 is equal to 21 in base 4. We're going to take that first digit, and then we're going to carry the 2, right, this 2 here. And where are we carrying it? We're carrying it up here, right? So for this place. And then we have 3 times 2 plus 2. So what's that? That's 6 plus 2. That's 8. So we know what 8 is, right? 8 is just 2 times 4. And it's just going to be 1 less than 9. So that'd just be 20. So we're going to take that first digit, 0, and then carry the 2, which, again, there's no other place here. So we're just going to put the 2 down here. Then we're going to add these numbers together. Same thing that we did in decimal. And what do we get? We get 0. We get 2 plus 0 is 2. 2 plus 3 is 5. Well, we know what 5 is, right? We did it right here. So we're going to take that first digit, 1. We're going to carry the 1 there. We have 3. That's fine. We've got 1 plus 0. That's 1. And then 2. So our final answer in this case would just be 2, 1, 3, 1, 2, 0. Base 4. That's it. And we know that our answer is probably right. I mean, we've got our answer written in the form of 0, 1, 2, and 3, right? There's nothing greater than that. We could go check it by converting it back into decimal, but you can trust me. I think that should be clear enough. Let's do another example. So base 5, same thing as always. Let's just write out what we've got. Base 5, we have 0, 1, 2, 3, and 4. So notice it's just the last possible digit you have is just 1 less than the base. So, base 4 would have 3 as a max. Base 10 has 9 as a max. Base 11 would have 10 as a max, right? But like if you had base 11, you would have 0 through 10, I guess. But, 10, they use like letters. So then that's how you'd extend it for something greater. but we're going to do it like pretty small bases because it's really relatively easy to understand. Let's do the same thing. We're just going to check for if our values here overflow over 4, and then we convert it if so. So what's 2 times 2? Well, that's just 4. Okay, that's fine. 2 times 3, that's 6. So we don't have 6 there, so we need to convert it into base 5, and that would just be 5 times 1 plus 5 to the 0. I like writing it out like this because it becomes easy to understand. So it's just 5 plus 1, right? So it would be, times 1. So it would just be 11, right? Because you take these digits here. And so that means that 3 times 2 equals 11. Take that first digit, carry the second. So what do we have? We have 2 times 1, which is just 2, plus 1, that's 3. That should be fine, right? And then 2 times 3 again, well, that's just 6, and we've already done that calculation right here. So we can just say, okay, put the 1, carry the 1. Okay, there's nothing there, so we do that. Next, we add our 0, like always, and I'll just put the extra 0 there just to make it clear. And then the same thing. Well, you notice that we're multiplying again by 2 to every single digit. So what's going to happen is we're going to get the same result, but they're going to be shifted over, right? Because we're starting in a different place. So we could just write it again. We don't need to do all that calculation again. So that'd be there. All right. Then we add, and then let's go. So let's just see if our addition doesn't overflow over 4. It's relatively easy. If it does, then we'll just have to do a little bit of conversion, but that's not too bad. So what's 4 plus 0? That's just 4. 4 plus 1 is 5, so we don't have 5, right? So we're going to need to convert it. So 5 is just going to be, it's either just 5 plus 0, right? Or it's just 1 less than 6. So since 6 is 11, well, 5 is just going to be 10, right? So we're going to take that first digit here, 10, carry the 1. We get 5 again, so we're just going to put 0 and 1, right? Same thing. And then we get 5 again, so we carry that. And we get 1 plus 1 plus 1. That's 3. That's fine. And then lastly, just 1. So our answer should be 130004 base 5. And notice I've basically done the exact same method each time. And then finally, you get to the part where it's like, how does this apply to digital logic? Well, base 2 is what we work in. So let's do an example in base 2 using the exact same methodology we just used. You don't need to memorize any complex method. Just remember what you already know how to do. So base 2, what do we need to know? Well, base 2 just has 0 and 1 as our two values. We just do the exact same thing. If our multiplication overflows to something like 2 or 3 or something greater, then we need to convert it into base 2. However, when you do multiplication between 0 and 1s, there's no way for it to get over 1, right? Because 1 times 1 is the, maximum that you can have. They'll always equal 1. But when you start to do the addition, like the addition portion that you get here, you can start to overflow, and that's where we'll see it. But this multiplication part is actually relatively easy. It's the exact same thing that we do in decimal. But let me move this over so I have a little bit more space, because I think this one will be a bit bigger, because we've got 4 digits on the bottom. But yeah, let's start. So we multiply 1 by 0, so that's just 0. 1 times 1 is just 1. 1 times 1 is 1. 1, right? 1 times 0 is 0. 1 times 1 is 1. Notice, because it's in binary, if there's a 1 here, basically you just copy whatever's there, because you're multiplying it by 1. There's no change. And then we add our 0, like we always do. And then, we multiply 0 by all of these things. Well, since it's 0 times everything, 0 times anything is 0. So we're just going to add how many zeros? 1, 2, 3, 4, 5, 6, because everything is going to equal 0 here. So we have 1, 2, 3, 4, 5, 6. I'm going to add 2 zeros now, right? Same as normal decimal multiplication. And then we have a 1 down here. So it'll just end up being the exact same thing as this, right? But we're starting here. So let's do that. So we have 0, 1, 1, 1, 0, 1. Honestly, this is a lot easier because then you don't have to redo the calculations. And then there's another 1, so it'd be 0, 1, 1, 1, 0, 1. Okay, so that should be fine. And now we have to do that addition, right? We have to do this big addition, and hopefully nothing overflows over 2, but if so, you know, we're able to convert it. So how do we do this? Well, let's do the first column. So first column, it's just a bunch of zeros, so add those all, you get 0. You know, we've got 1 plus 0 plus 0 plus 0, that's just 1. Same thing for the next column. But then we've got another one, which is 1 plus 0 plus 1 plus 0, which is the same thing as just 1 plus 1. And that's 2, right? So that gives us 2, but that doesn't fit in base 2, so we need to convert it into binary. Well, this is relatively easy. You guys have been working with this a lot, so base, you know, it would just be 1, 0 in binary, and then, you know, take that 0, carry the 1. And then for the next row, we have 1 plus 1 plus 1, so that's 1 plus 1 plus 1. That gives us 3, right? Or in binary, 1, 1. So we take that 1 and carry the 1. And then for this one, we've got 1 plus 1 plus 1 plus 1. So 1 plus 1 plus 1 plus 1. That gives us 4, or 1, 0, 0. Right, now we've got 3 digits, so what do we actually do? Well, we still take that first digit there, and then we carry this whole second part. So, you know, we carry this 1, 0. You can also just write it out as 2, right? Because that is what it is. It's a 2. So let's put a 2 there to make it a bit simpler. But it's still 1, 0. It doesn't really matter. And then we do 2 plus 1. That's 3, right? So what is 3 in binary? Well, we just did it here. It's 1, 1. So we're going to put a 1 here, carry a 1. 1 plus 1, that's just going to be 2. So we're going to put the 0 and then carry the 1. Same thing. Carry the 1. That's it. So then our final answer should be 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, base 2. So don't overcomplicate things. Just realize and recognize that, you know, the methods are all the same. You've learned this from when you were younger, but you know, you don't need to think too hard about it. So you don't need to like memorize, oh, these are the steps for shift and add. Just remember that you could do this for any base. You just have to look, when is there an overflow, and then, you know, compensate in this type of way, the same way that I did here in each of my base conversions, but just compensate when you need to. So yeah, that should be it.